So hello everyone, thanks Aino for the introduction. As said, my name is Katri Kakko, and great to see so many of you here today. The first slide, engineering for your success, that's straight from our marketing material, but I thought it fits quite nicely to the theme of the day. Shortly about myself. So I have my educational background in material science and engineering, with my main focus on materials characterization and my thesis in powder metallurgy. How I first got there, was through, maybe just pure luck or coincidence. I had a discussion with my dad who said that, okay, he read an article where it said, if we would like the gender pay gap to decrease, so women get paid more than we get right now, more women should actually apply for technical fields or other fields which are traditionally seen as male-dominated. So I thought, why not? Engineering could be fun. And how I got to the current position as development manager for EOS was through another company where I did an internship where I was first introduced to additive manufacturing. And that, for me, was something amazing. I just fell in love with additive manufacturing. At the time of my graduation, there weren't too many companies, maybe one or two in Finland, who did additive manufacturing. So it took a bit of hard work, other jobs, but eventually my persistence paid off and I got a position at EOS. So that's where I'm today. And why I'm here today telling all of you all of this stuff is unfortunately not because I would be a very talented speaker or because I would have a very specifically interesting career. But it's the sad fact that in our R&D, I'm the only woman. So when they asked us, it was quite clear who should do the speech. But yeah, and I can show you that this is me trying to convince my son that technology is interesting. That's actually one of the most heavily modified AM machines probably in the world. But as you can see, he's not entertained, he's not interested. But anyway, so if I'm lacking the speaking skills, at least I have the passion. And if nothing else, I'll try to be quick, so bear with me. So what is this technology that I'm so passionate about? You might know additive manufacturing as 3D printing, and it's probably something I hope all of you who want to test it get to test it today in the workshops. Basically, it's just a way of producing parts by adding material layer by layer instead of removing material from a larger chunk of material. And it obviously brings great benefits for a large field of applications. For example, in tooling, the parts usually or always require some kind of cooling. The freedom of design allows for more complex cooling channels, and that extends the lifetime of these parts. So we need to we can reduce the amount of parts that we have to build. In heat exchangers, for example, freedom of design can increase the surface area, which increases the efficiency at which the machines are working. In engine parts, you can directly reduce the weight of the parts, which brings fuel savings. In medical industry, higher degree of customization can allow for better usability for the patient. And obviously for other industries, just, having a part where you add material instead of removing it, you reduce the waste already when you produce it. This is a engine hold. Probably my male colleagues would be, better in telling where this goes in a race car. But I thought usually when you talk about 3D printing, you show something that's plastic and something that's small, but that's not the whole truth. So you can build something that's relatively big and made of metal. In practice, what I do, basically my work revolves around these 3 topics. So you will need a system or a machine to build the parts. From materials perspective, you might have to tell the machine that, okay, we need heating to avoid bending of the parts. You might need an inert gas to avoid oxidization, so your copper parts don't turn blue while printing. Well, the material side, I work with powder materials. You might do something else today, but when you're working with powders, you have to think about, for example, what size the particles should be. And in the case of EOS, we do the building with a laser. And there you have to tell the laser how much powder are we using, at which speed does the laser travel. So those are just the few variables that we have while we're doing this R&D work. And I think that's the best part of it. It's like a good puzzle. You never know what's going to happen until you really test it and see it. And basically, I think that's the reason why we are all here. To get the best results in R&D, you need diversity in the teams. I can't be the only woman there because then, we might do something that's too heavy or, I don't know, whatever. But we need bright ideas, we need various ideas, and diversity is the key there. I'd like to say you don't have to be specifically smart or specifically passionate about technology to apply for technical fields, but just be curious, test it and see if you like it. With that, I conclude my presentation. Thank you for listening. Also, thanks for not, starting to cry and roll on the floor. It means a lot to me. Thank you.